Welcome to the pre-lecture 3 video. We have already finished up experimental design, talking about which studies are strong and which studies are weak. And now that we've collected this data as researchers, we need to know what to do with it. You recently took a survey asking you a series of questions, and one of the questions was, how many pairs of shoes do you own? Well, we have about 1,000 responses, and we could just dial through that Excel sheet until our fingers are sore. But really, what conclusion can we come to just with a list of numbers? We need to have a way to describe this data, to be able to analyze it visually, to get a better understanding of really how the data is laid out. So this is why we're beginning descriptive statistics, taking these numbers and being able to translate them into a visual property so that we can truly understand what these statistics mean. So, in your survey, we asked you how many pairs of shoes you own. Let's take a look at 2 ways that we could potentially display this data. First is the bar graph that we know and love since 3rd grade. And the bar graph, the most important feature of the bar graph is the height of each bar. On this bar graph, we have broken down your data based on the number of shoes that you own into different intervals. We have the 0 to 5 pair category, the 6 to 10 category, 11 to 25, 26 to 50, and 51 to 100. The first thing that should be popping out to you is, these are unequal widths. These are unequal intervals. 0 to 5 is a measure of 5 pairs of shoes long, but 51 to 100 is 50 pairs of shoes long. And yet on a bar graph, you'll notice that the widths of each bar are represented equally, regardless of how wide of a span that this width is trying to summarize. So we're able to condense this data down and basically eliminate the factor of how wide the x-axis is supposed to be. We just break them down into categories and only analyze the height. You can already see that there would be some flaws here, that this is looking like quite a normal curve. So you might think that if you own 55 pairs of shoes, that, oh, you're just on the high end of normal, right? That's just the way that this graph is trying to display things. So bar graphs do have a place in society. I'm not trying to eliminate them. There is a place for bar graphs. But the place for bar graphs is really with categorical data, where the x-axis really doesn't matter. For instance, if we asked you, what's your favorite color M&M? Even though there's no flavor, everybody has their favorite. And we had this as, you know, I like the red M&M, I like the blue M&M, I like the green M&M, and so on. A bar graph would be perfect to represent that, because there's really no difference between blue and red in what they're trying to represent. They're equal categories. So it would make sense that we would display them in an equal width. We wouldn't make the red bar wider than the blue bar, right? So that is why bar graphs really come in handy with categorical data, where the width does not matter. Because when we start to apply the bar graph when we start to apply numerical data to the bar graph, as you can see with our intervals, the researcher could really manipulate how wide of an interval each width is supposed to span to their advantage, to distort the numbers, to try and convey a point. So you could see that this really has a place for categorical data, but could be, in the wrong hands, quite dangerous with numerical data. So let's look at the exact same data, the exact same numbers, displayed on a histogram. This might be brand new to you. This is a histogram, and immediately we can see this doesn't even look anything like this bar graph. I assure you, this is the exact same data. Now, a histogram is different in that the height is extremely important, but the width is also incredibly important in reading a histogram. And you'll notice that on the bottom we have this continuous scale from 0 to 100, and the widths of each bar are drawn in a way that represents how wide of a span that bar is spanning. So we have 0 to 5 is much skinnier than 50 to 100. They're representative of how wide that data is supposed to cross. So when we read histograms, because there's 2 elements now, height and width, where are we supposed to get the information from? Well, the true information, the true data, lies in the area. Right away, looking at this histogram, we can tell the bulk of the class appears to be down here, around 10 or so, and that very few individuals in our class are hanging out around 100. So it gives us a more representative data about how the class is really spread out throughout this continuous scale. Now, how do we go about actually reading the data to actually be able to interpret what it's trying to tell us? Well, if we wanted to understand what percentage of people lie between 0 and 5, what percentage of our students have between 0 and 5 shoes? Now remember, both the width and the height of the block matter on a histogram. So it's important to remember that the golden rule for histograms is that the entire area of the whole curve always equals 100%. The area under each and every block will add up to equal 100% of the class. So 100% of our class is represented somewhere in these blocks. So if we wanted to understand the percentage of the individuals within each block, we just find the percentage of that block, the area of that block. Because the percentage of individuals within a block is represented by area, which is the width times the height. So let's examine this first interval of 0 to 5 shoes. We know that this has a width of 5, and it has a height of 2. 2 what? 2% per pair, meaning the percentage of students that own that individual number of pair of shoes. It basically is telling us that the width of the block tells us how spread out this interval is. But the height of the block goes on to detail of telling us how crowded the number of people are within this block, how densely packed that interval of shoes is. So it's percent per shoe, per pair of shoe. So we have a width of 5 and a height of 2. So there's our width times our height, which gets us 10%. 5 times 2 gets us 10% of the class has between 0 and 5 shoes. So let's go on to the next one. The width of the next interval is between 5 and 10, which is going to get us, again, 5. So this is an interval of 5 pairs of shoes. And the height on this one goes all the way up to 5. So our width times our height is 5 times 5, meaning 25. So even though the first two intervals are even, they both represent 5 pairs of shoes, we can see that more people have between 5 and 10 than they do 0 and 5, because this second block is higher than the other one, indicating it's more crowded. More students lie within this block than that block. Then the next block we have is between 10 and 25. So this is a longer block of 15. So our width is 15 and our height is 3. So I'll put the height right on top in parentheses so you don't have to strain your eyes reading. So 15 times 3 gets us 45. Wow, 45% of the class has between 10 and 25 pairs of shoes. The next interval, 25 to 50, is 25 pairs of shoes long. And it goes up to a height of 0.6, I believe, which gets me, what is that, 15. So 15% of the class has between 25 and 50 pairs of shoes. And last but not least, we have this long 50 shoe pairs interval that goes up only 0.1. So this, our width is 50, our height is 0.1, which gets us an itty bitty 5%. Right there is our last one. So now that we know how to read a histogram, you can tell that the histogram is able to depict the actual percentages in a much easier way, in a much more visually pleasing way than the bar graph. Do we have any questions?
How did you get the 15% again? What did you multiply the?
Yes, you're right. I forgot to write this up on top. The 15% came from a width of 25 times our height, which I looked over here on my axis and saw that it was 0.6. That's our height there. So when you're reading these histograms, usually the height is listed in parentheses on top of the bar graph, or on top of each bar. And either way, you could always just, use your vision to try and eyeball it yourself, but the exact number is always going to be written on top of each bar. Any other questions? So in lecture we're going to go into more detail about histograms, and there's another video that teaches you how to draw your own histograms given the actual spreadsheet of 100 pieces of data. So I hope that this has been a useful video, and I hope that I've recruited you to Team Histogram, which we will be using a lot of in this course.